So, we will look into concepts of energy conservation codes, right, and we will look into this one first. Obviously, it has changed now. So, with as we shall see sometime later on, many countries have adopted these codes as early as 1980s and 1990s, right. So, first we are looking at this Indian code, then we will look into some other, generally some other code. So, the code tends to restrict the consumption of energy in buildings, right. Obviously, it is in the context of conditioned building. It is in the context of conditioned building, right. So, basically is to provide minimum requirement for energy efficient design and construction of building, but it also takes care of all other aspects. For example, the lighting, all other lighting plus other active systems. So, it gives you a guideline so that this is minimized, but we will largely look into the issue of envelope and construction. Now, scope of such code would be, and this is of course to Indian scenario. So, it is to all buildings and building complexes that are connected to 500 kilowatt or greater, contract demand of 600 kVA or greater, right. So, anything above 500 kilowatt consumption or 600 contract demand, that is basically consumption is usually less than. So, your power lines are designed for this much kVA, this much in terms of kilovolt. This is the consumption actually, because this would be multiplied by a power factor in alternating current situation, and then you might be using it sometime and may not use some other time, although your design is for 600 kVA capacity, but this is consumption. So, generally building or building complexes having conditioned areas 1,000 square meter or more will be there. So, anything less than that, of course, you need not look into this, but anything more than that, one definitely must look into it. So, this applies to, as I said, it applies to this code, this particular code applies to building envelope. Of course, unconditioned spaces you need not look into, or storages, warehouses. In the building complex itself, there is some portion is storage, you need not look into that. Then mechanical system, equipment, that is what I said, HVAC system, heating, ventilating and air conditioning system. So, it applies to this. So, it course gives you a guideline related to that as well. Services, hot water supply system, interior and exterior lighting and electrical powers and motors, everything. So, they give us given guidelines for consumption, minimum consumption. Well, some exceptions are made because the code. Now, generally, why do you need codes actually? Codes you need once you have to have kind of a restrictions or control. Some other cases you need code, of course, where you do not have very objective way of estimating things. For example, in civil engineering practices we use codes in design, most of them because we do not have very objective way of estimating, let us say what should be the, like there are several issues, crack width or things like that in reinforced concrete and so on. So, some of them are because subjectivity is involved. So, their code brings everybody in same platform. Some cases you need standardization. Now, here of course is largely because you want to have a control, right. In this particular type of energy code should be, you do not want unnecessarily wasting the energy. So, that is why you need this. So, therefore, if a building which does not use fossil fuel at all or electricity, you do not have to consider this. If the energy is used for manufacturing processes, that is an industrial building, again this is not, that energy is not to be considered. And obviously, safety, health and environmental codes, safety, health and environmental codes shall take precedence. Obviously, they will dominate. So, the energy code cannot override structural design code. If the structural design requirement is something, you cannot override that through these codes. All right, compliance of these requirements of energy code shall be mandatory for, because in India, unlike many other countries, codes are under central government control in a way. Indian BIS is a government, in a way quasi government, if not government fully, body controlled by the government largely. But on the other hand, if you see California building code, let us say, or energy, something of that kind, that is not statutory. In US it is not statutory, they do not have something like American standard institution. So, many countries have, many countries do not. So, there are varieties depending upon the country, and in India they are trying to make it mandatory by and large through the code. That will come through Bureau of Indian Standard, which has recognized this, and many aspects of it is actually taken in International Building Code. The latest code is of course 2019, which such as the Bureau of ECBC code as we call it, Energy Conservation Building Code, Energy Conservation Building Code. Latest one is 2019, and some aspects of it I will bring out later on, right. We will look at it sometime later on. New buildings shall comply either with the provisions of this code or some sort of energy budget method it should actually account for, right. It should take care of. Okay, where addition plus, if you are adding something, the existing building exceeds the conditioned floor area of the threshold, addition shall comply with the provisions of the code. So, where you are adding something, say earlier area was let us say 900 meter square, with consumption whatever it is. Now, you have added something goes beyond 1000, now it goes beyond 1000, is greater than 1000 meter square. Then addition, because we said that minimum is 1000 meter square meter, if the building is, if area, floor area is less than 1000 meter square, then I may not apply this code. But if it is now more than that after addition, then the addition shall comply with the provisions of the code. Whatever you have added 200, maybe made it 1100, let us say. So, that 200 meter square, that additional part must comply with the requirement of the code. Yeah. So, the addition shall alone shall comply with the applicable requirements. If it is a new building, if it is also both, the addition should apply and then overall also it should comply, because the addition together with the entire existing building shall comply with the requirements of code that would apply to entire building as if it were a new building. So, where existing building exceeds the conditioned floor area threshold and its system building and its system that are being altered shall meet the provisions of the code. So, if you are doing any alteration and already existing, so you can't do much about it, but any alteration you are doing, that should apply. Alteration to the building envelope shall comply with the requirements for fenestration, insulation, air leakages, etc., the portion of the building system being altered. So, whatever you altering obviously it would have, it will apply. Okay. Administrative requirements such as permits and interpretation, claims, exemption, approved calculation methods, because after all it has to be estimated. If the building does not exist, I cannot measure it, and even if it exists, you can at best measure for let us say 1 year or 2 year consumption, but code cannot wait for that. So, during the in the initial phase itself, the code will apply. Therefore, I should have methods of estimating what is the annual energy consumption in the building. So, these methods are basically approved methods shall be right, and rights of appeal, okay, that etc., appeal etc., having authority, having jurisdiction and all that, that would look into this, like municipal authorities, they should be there, but it has not come to that stage in India. Plan and specifications show all pertinent data and features of the building, equipment, system in the sufficient to permit the authority having jurisdiction to verify. So, therefore, verification is required, then you need all details to be given, right, and details shall include, but not limited to, of course, building envelope. So, that is the point that I am trying to make, building envelope, HVAC, services, hot water and pumping and lighting and electrical power, right. So, these are the 5 components actually, and I think now by this time it is by and large clear to us that this is one of the major thing which governs, which concerns really us, right, because building envelope, their U values, solar gain coefficients, heat gain coefficients of glasses, light transmitters, air leakages, etc., and then shading device, any ceiling, because you do not want infiltration, air infiltration. So, these are the part of building envelope that should comply with the codal requirement. HVAC size system, because there are improved system now available and possibly they will get improved further. Efficiencies and controls, kind of economizers, variable speed drives, piping insulation, etc., etc. This is the. So, we will not look into this much, but we will look into the codal provision related to this, most of it. Service, hot water and pumping, of course, solar water heating system if you have, and lighting schedule. I mean, if there is a lighting schedule, that means that all the time lights are not on. So, if there is a lighting schedule showing type, number, wattage, lamp, etc., automatic lighting, shut off, occupancy sensors, other lighting controls, these are all fall into this category. Again, we will not going to look into this. So, this is all related to artificial lighting. So, we will concentrate more on this, but we will see what is there in the code. And electrical scheduling showing transformer, losses, motor efficiencies, everything, and power factor correction devices, correction devices if required, because alternating current, some amount of energy stored. If you have an inductor, or like motors where you have magnetic, it's in inductor basically alternating energy, current energy stored as magnetic energy, and it is stored and released, not consumed. Only the heating I square R, that part I square R T, that is I square R is a watt. So, that is what is utilized. So, that is what is the energy basically. So, therefore, power factor corrections we do actually to maximize the, there are, I think, building services system, if you look at it, you will understand that, but I think I am not interested right now in this. So, electrical check metering and monitoring system, all those devices that being used for electrical system, that also forms part of it, but then we are not really interested in this. For our purpose, we are interested more in envelope. So, this we already have said, U factors already we have mentioned what are these, what are U values, right. So, for glass, for example, fenestration means glass, in according to which code and how will you determine, that is given, right, and the values determined should be through some sort of measurements done by approved test houses or laboratories, etc., and certified by the manufacturer or other. Like for example, if it is a IS standard, Indian standard stamped, so that kind of thing. So, what is the U value of the fenestration glasses? These are important. U factors for sloped glazing, skylights, etc., etc. For unrated product where the rating is not given, one can make use of some data. So, this information is available, this is given in the code. Then the solar heat gain factor of the glass, if you recollect, we said that the fraction of energy that will enter into the through the glass divided by what is incident, that is what we call as solar gain, heat gain, I mean solar heat gain coefficient. So, this also again it code gives you how it should be determined. Then infiltration is very important, and the infiltration maximum limit values are again given, right. So, air leakages for glazed windows or swinging entrance doors, etc., and revolving doors should not exceed 5 liter per meter square per second. So, air leakage for other fenestration should not increase. So, for the sealing of the windows and etc., so that infiltration rate is less, that is also given in the code. For walls, U values are should be determined, and again values are given in appendix, or you can determine according to certain standard code. So, this is what it is. Okay. So, it also says that following areas enclosed in a building envelope should be sealed, corked, gasketed, chalked, gasketed or weather stripped to minimize air leakage. So, joint around the openings, windows. Fenestration is basically openings meant for deliberate openings meant for air ventilation or lighting purposes. So, if you have glasses or windows, there should be door frames, there should be the ceiling applies to this ones. Opening between walls and foundation and between openings between wall, roof, etc. Opening at penetration of utility, for example, a pipe duct is coming. So, the leakages should be shall be sealed totally. This area should be sealed, and utility services through roofs, wall, floor, etc. So, any pipe coming in, that area should be sealed. And if it is built at the site built fenestration and doors, that is windows and doors, building assemblies used as duct or planum. Now, this is done precast elements. For example, you can have concrete ducts, right. So, part of the assemblies is a part of the building itself, then there you would require complete sealing. All other openings in the way. So, basically what it is trying to say is openings in the openings which comes because of poor construction. If everything was done, sizes are all fixed, construction quality is good, you will have very little leakage. But even then there might be some, and they should be sealed. So, they should be completely sealed. Therefore, so that your air exchange rate is minimal. Remember, I talked about air exchange rate sometime. I might have mentioned what is it, air exchange rate. Air exchange rate, air changes, number of air changes per hour, that is the total airflow in 1 hour n times multiplied by the volume. Air change n, number of n air change means, this I think I did talk sometime earlier, n air changes per hour means that n into volume of the room per hour, that will be the flow. So, that's basically, you do not want this to be high, because if it is high, if the flow infiltration rate is high, then outside air is warm, it will bring in heat together with it, right. And if it is cold climate, then it will take away the supplied heat into the room to outside. So, therefore, you do not want this to occur by default. Windows ventilation, these are by design. When I need it, I will use them, but infiltration is by default through leakages, etc. So, that has to be controlled and minimized, and that is what is done through sealing. So, that is the one thing, right. So, this code deals scenarios, actually it gives, it tries to look into 3 approaches actually it has. One, what we call prescriptive requirement. So, it says that it simply gives you the value, prescribes this should be the insulation value of the wall or roof. The other one is you can calculate this out and satisfy a requirement of your envelope, all properties, and that should be good enough. So, roofs shall comply with either maximum assembly U factor. So, these U values are prescriptive values are given, the values are specified. So, if you are looking into a building and you want to see that whether it is ECBC compliance or not, one way is to look at the prescriptive requirements, which is not a very best thing, because it leaves very little to the designer for choose from, because it is already prescribed. So, there can be a trade off possible. That means, I have high U value somewhere, there will be low U value elsewhere, because that amount of heat that will come in is equals to U into delta T, U into area into delta T, that is what we talked about for opaque bodies, and delta T is the temperature difference between outside and inside at a given instantaneous heat flow will be like this. So, overall if I have to find out, there are more of course complex way, but then this property is the one which governs. So, it is this code tends, one way is it prescribes simply the values of U. Other ways it allows for a kind of trade off, and third one is what we call whole building performance, which you estimate through some software. So, the software which are actually also kind of software, or the software or methodology, in a way it is actually prescribed some sort of some guidelines they have given for which kind of software or what software can be used, some ideas guidelines they have given, and it has to be approved by the appropriate authority. So, using those softwares you can actually estimate the annual energy consumption. For example, I was mentioning EQST is one of them, Energy Plus, there are several softwares which they have actually given. So, using those one, you will find out the whole building performance, and this whole building performance compared with a given type of standard building for the same floor area, etc., you try to they defined a standard building and calculate the whole building energy consumption, annual energy consumption for the standard building and your design. They should it should be less than the standard design that they have suggested for the given floor area, given occupancy, etc., whatever they have suggested. So, first is let us look at prescriptive one. There is a maximum U value factor is given in the code table, or minimum insulation, because 1 over U is R resistance. So, this is given. This is given for the insulation alone, does not include the structural element, right. Building material, or if there are air films and things like that, shall not be located on a suspended ceiling with removable. So, therefore, what insulation minimum you should use, that is the guideline gives you, that is the guideline gives you. Similarly, if you are using something called cool roofs, right, with slope less than 20 degree shall have an initial solar reflectance. So, this is a kind of prescription that is given, and initial emittance not less than 0.75. So, these are the kind of guidelines given. So, the approach is, values of course you can always look into the code and find out, but the reason for this is prescriptive. So, they have given you the insulation, minimum insulation you should be using, and minimum these properties, those are one should be using. For example, this is what it is. Two types of buildings are given, 24 hours application and daytime use building only. So, if you use 24 hours building, like hospitals is a typical 24 hours building, hotels, things like call centers and so on, and residential building or office building, let us say, it will be only daytime use. So, maximum U value for different climatic conditions are given. For example, for composite monsoon climate, this is 0.261, and minimum value of insulation alone is also given. Minimum values of insulation is also given in terms of 1 by U. So, maximum value is U by give overall, and this is for the insulation alone. So, first you check the U value of whatever is existing, and then you provide minimum 1 over this, R is U, U is 1 over R. So, therefore, you can calculate out, because you remember we said 1 over U is equals to 1 by HO plus R1 plus R2, R3, etc., which was L1 by Ki, if you remember, plus 1 by H naught. So, minimum value of insulation required, that one can check, and for for maximum value of U for only daytime use building, these are the values given. So, this is given for different climatic condition of India, and I think I might have mentioned that India is divided into these 5 climatic zones. I am not sure whether I have mentioned here in this class, but let me just tell you then what they are, right. So, there are 5 climatic classifications in the country. Did I mention? I am not very sure, but let me repeat it. Central, if you look at it, there is an northwestern side around the desert, third desert, Rajasthan. These areas are, you will have almost desert climates which are characterized by high variation of day and night temperature. Day temperature is very high, night it is very low. Very little precipitation, rainfall is low. Relative humidity is generally low. While if you come to coastal area and northeast, those areas, rainfall is very high, diurnal variation is, day and night variation are not so much, but relative humidity is high throughout the year, right. Throughout the year it is higher, at least 6 months it will be falling into a given kind of category of this, where the relative humidity is above certain value, mean temperature is above certain value, etc., etc. So, those areas we call as warm humid climate, those areas we call as warm humid climate, right. So, warm humid climate and desert climate, hot dry, so desert climate there is given. So, they are calling it hot and dry, that is the desert climate, and warm and humid is this one. Now, moderates are some modification of these climates, or largely this and once in a while this also, because of altitude. For example, over the Deccan plateau the temperature variation is relatively less, it is almost comfortable condition, that is what you call maybe around 25 and relative humidity around 50-60%. So, that is more or less. So, moderate climate is somewhere there. Now, where 6 months belong to this, or 6 months or more belong to this, or 6 months or more belong to this, they fall into these categories. Where 6 months falls, 6 months falls into this, they fall into this category. Cold is where temperature is very low, like Himalayan areas, some on the hilltops. So, that those areas temperature is much lower, relative humidity may be high, but temperature is much lower. So, they follow into cold climate. For example, Ladakh, J&K, they will be all cold climate. And where none of this category is more than 6 months, that is composite. That means, in that one part of the year you will have this climate, part of the year you will have this climate, and maybe sometime you may have somewhat cold climate as well. So, that is like central Indian condition, it falls onto those. So, it is May, June before monsoon, this is the this is the climate you find, and during monsoon period and just beyond you find lot of humidity, lot of rainfall. So, rainfall etc., etc. This will be Mumbai, Chennai etc., alone. This is Delhi, Nagpur and so on. This is Jodhpur, Jaisalmer, those area. Jaipur of course belongs to this, and cold climate will be something like Leh, Shillong etc., those kind of Shimla and so on. This is Bengaluru would be moderate climate. So, this is how it is. So, therefore, for various climatic conditions, this R values they have specified, and U values they have maximum values they have. So, if you just check yours, and if it satisfies, fine. This is for roof assembly, and if it does not satisfy. So, therefore, the actual compliance is pretty simple on drawing board. It is not on table, it is pretty simple, but then this does not allow you to designer's choice become very minimal, because it is already prescribing. Supposing designer tries to optimize orientation, shape etc., and try to reduce the energy, then this is not talking in terms of really orientation etc., only building type it is given. So, it is a very gross kind of prescriptive one. So, one can look into that, and the choice, then you do not have much choice available. So, walls, opaque walls like brick wall or block masonry etc., walls, this wall shall comply with maximum assembly that is given R value, and in the similar manner. So, this is for wall assembly. Same for this climate, and these are the values for 24-hour and these are the values for daytime application only. So, this is how the prescriptive guidelines are given. Then it gives you maximum area weighted U factor for glasses. Now, glass will have frame, window will have frame also, right. So, some glazed area, the frame portion also. So, take weighted average, for example, W1 area, which will be area, or let me put it like this, area 1 of the frame, U frame plus area of the glass, U of the glass, right. This divided by total area AF plus will be area weighted average value of the U. AF plus AG will be the area weighted. So, fraction of the area of the frame multiplied by the U of the frame, fraction of the area of the glass multiplied by U of the glass, that is the area weighted U factor. And also HSGC requirement, that is your solar gain factor, because I said that AI theta is the amount of heat that will come in, where this theta is the solar gain heat, because the fraction is the proportion of heat that will come in divided by the incident radiation. So, AI theta, I is the incident radiation area and this is theta. So, the theta values, maximum area weighted SG requirements are also given. In that case, this fraction will have no SG, this will be 0, because it will be AF theta F, let us say, plus AG theta G divided by AF plus AG. Now, this will be 0. So, only that fraction of the window you should be taking as area, which will bring in the solar radiation. Now, if you are using different types of glazing by chance, which in that case in the building there will be different glass doors, they might have different. So, then you have to use this together. So, then you have what is called overhang sunshades and vertical fins. You know, vertical fins, because you have vertical shading devices, I mean fins, you know, this is your, let us say this is your wall, this is the wall, and then there can be vertical fins. So, these side fins applied for determining, you know, that also you should be actually you can apply, because some proportion of the solar radiation will not enter. If I have a overhang, this will block the sun radiation up to this point. So, till the sun is here, and when sun comes here, this will come in, this will not block. So, therefore, that proportion I can take into account, that is what it is saying, right. Overhang side fins is calculated multiplying the SHGC of the unshaded portion product times multiplication factor. So, this is called solar shading multiplier, you know, that one can calculate this out. I am not sure whether I have included this in this part of the course, but we will see. But essentially you can find out how much area, for example, this is my overhang, the sun is here. So, this portion will be shaded, this portion through which the sun rays will come through this. So, area available is only this portion of the window. One can calculate this out, one can estimate this at every hour, and then sum total for the whole day year you can do, in fact, or you know. So, that will give you the overall shading, this value multiplication factor, right, and M factor shall be determined for. So, for each orientation you can determine, and for unique shading condition, okay, etc., and then that you can add, actually, that is what it is saying. So, for the glass, these values are given, again prescribed values are given, maximum U value for the glass for different climates, this is given, and it allows maximum window to wall area ratio is not more than 60%. So, window area should be minimized if you want to reduce heat gain to a minimum, right, minimum. So, window area should be minimized. So, this is what maximum window area permissible is 60%, in fact, it should be less than 40%. So, if it is less than 40%, maximum SHGC is also prescribed for different climate, and this is prescribed for if the window area is something like this. So, I think that is what it is. Overhang factor we will just look into after we break and take few